Okay, so our goal, and we were doing this at the end of the first semester, our goal for right now, especially this chapter, is we're going to be graphing a lot of lines, right? A lot of lines. Chapter 5 is all about systems of equations and systems of inequalities. Today, in a little bit, we're going to go over exactly what a system is. But first, this is like a little practice, like a little review. We want to graph. We want to graph these 6 equations. What the heck, Mr. Wallace? I don't even remember how to do that. Well, if you guys remember in the warm-up page that I got you, my main thing of graphing is there's multiple ways to graph. You know, the intercept method, which is what we did kind of midway through the semester. I love slope-intercept. Slope-intercept form. Y equals mx plus b. All right? Our goal is to get the y all by itself. All right? I told you guys we're going to be doing a lot of graphing, so here we go. All right? Now, for number 1, pretty easy, hopefully. Someone unmute themselves. What is the one step to get the y all by itself? What do I have to do? Someone go.
Subtract 2.
Subtract 2. Marissa, thank you so much. All right, guys, so look what I'm going to be doing. Are this x and the negative 2 like terms? Are they like terms? Obviously, no. They're not like terms. We have a constant and a variable. So I'm going to rewrite this equation. Okay. Someone real quick. I'm going to be calling a lot. I'm going to be calling on a lot of you guys. Sorry if I sound so congested. Part of my 6 miles is being outside, and you know we talked yesterday about how my allergies are still so bad, like some of you guys is. I'm going to be calling on a few of you. Why? Someone unmute. Be brave. Why would I put the x first and not the negative 2? Technically, I could do y equals negative 2 plus x, but I want the x first. Someone go ahead, unmute. Tell me why.
Because isn't negative 2 the y intercept?
Yes! Oh my gosh, Stevie, awesome job. Give yourself a pat on the back, Stevie. Just like that. Awesome job. Negative 2 is the y-intercept. We want it in this form because that is in the exact form of y equals mx plus b. So guys, if we get the y all by itself, we're done. We can now graph, right? Like Stevie said, my y-intercept is negative 2. So that's where my line starts. That's my starting point. So there's my y-intercept. My slope, someone unmute. What is my slope? It's not x. What's the number before x? Someone go ahead.
Your slope, oh wait.
Go ahead, Angel.
Well, usually it's the number before x. There's no number.
Yeah, so what number is there if there's no number?
1.
Yes, good job. Awesome job. So, it could also technically look like this. We don't really need the 1. If we have a whole number and it's positive, that means we go up. So up 1 over 1. Up 1 over 1. And we start from that y-intercept like Stevie said. Guess what, guys? We graph the line, right? We graph the line. All right, I'm going to do, it's already 8:30 or 8:25. If you guys have your Green Student Journal, I want you to try number 2 by yourself. So try number 2 by yourself, and then I'm going to go into the chat and then ask and see who got it right or wrong. All right, so if you don't have your Green Student Journal, please just, draw a little makeshift graph, and I want you guys to see it too, all right? Now, before we do anything, I would recommend putting it in slope-intercept form. Getting the y by itself. We are moving around terms and moving around numbers. Get the y by itself, but please note, the y has to be positive, right? So that y and y equals mx plus b has to be positive. All right, so I'm going to do it on my own in silence, and you guys get the y by yourself and then graph. I want to see what you guys get, all right? How many people do we have in here today? Okay. 24. All right. The one bad thing about the student journal is there's not a lot of space. So try to either write small or write to the side or something. And guys, I'm not just saying this, I'm your math teacher, but I really, especially in this student journal, want you guys to practice this because unfortunately I can't be there in person to see how you're doing. So it's very important to get this skill, ready to go. Because if you cannot graph, it's going to be a hard chapter. It is going to be, I'll say it straight up, if you can't do what I just did, it's going to be a hard chapter. All right, and I'm not being negative or anything about it. It's just I'm telling you. So, okay. All right, 2x minus y equals 3. All right, so in my quest to get, I like that word, quest. It's really epic sounding. In my quest to get the y by itself, I subtracted the 2x, put it over to the other side, sweet. Someone unmute, tell me what is wrong right now with this equation.
It's negative.
It is negative, awesome job. What do we do to get rid of a negative? Super, super easy. We divide everything by -1, right? Now, some of you guys might remember, oh, if I divide by a negative, we flip the symbol. Remember the inequalities flip the sign? Guess what? Is this an inequality? Nope. It's an equal sign. If I have an equal sign and I flip it, well, it's still an equal sign. So, obviously, when we're dealing with equals, we don't have to flip anything. So, just a reminder, that happens when we have inequalities. So, divide by -1. Let's do that. A couple people are getting booted. Oh. All right, so I divided everything by -1. Right, we have to be careful because that y now is positive because 2 negatives cancel out. These 2 negatives cancel out, make a positive. A positive and a negative make a negative, so that's why it's -3. So this would be something, guys, to where it'd be really easy to make that little mistake. And especially with graphing, if we get just one sign wrong, the whole line is wrong, okay? All right, now let's graph. Where does it start? It starts on my y-intercept, which is the b value. Now we have to be careful. My slope is 2. So since it's not a fraction, that means I'm going up 2 over 1. Because remember, guys, from last semester, if we have 2, that's the same exact thing as 2 over 1. And just like last semester, slope is rise over run. Rise over run. All right, so 2, even though it's not a fraction, my rise is 2, and it's positive, so I'm going up, and then over 1 to the right. We always run to the right. Up 2, over 1. 2, over 1. 2, over 1. Notice that because the slope is 2, the slope is a little more steep than the first one. You know, if at the slope of 1, it's pretty even diagonal. But this one with the slope of 2, it's just a little bit more steep. If we had a slope of 3, more steep. The higher the slope, the more steep the line is. Okay?
Mr. Wallace.
Yeah, what's up, Angel?
I don't know if this is right, but I did something completely different and not the same thing.
Okay, okay, Angel. That's what I love about math. There are multiple things that you can do and get the right answer. If you wouldn't mind telling me, what'd you do, Angel, real quick?
why don't I just move the y? So you know how some equations are like reversed, so the equal sign is on the right side.
Yep.
instead of the left?
Yep.
I the problem like that.
So I'm gonna recap what Angel said, guys, and this is some of you guys might have done this. All right, Angel, I love what you said. That is totally fine. All right, here's what Angel did. Notice, it's the same equation. That's what I started with over here. I chose to subtract the 2x, and actually, the way Angel did it is one less step, right? The way Angel did it is one less step. All right. So Angel, pretty much, he saw that y, knows that y's have to be positive. He added it to the other side, right? This is what Angel did. He added it to the right side. And then, I need to get that y by itself. I'm just going to subtract that 3, subtract the 3 over there. Guys, guess what? Are these two equations the exact same thing? The answer is yes, right? It just happened to be that the y right now is on the right, but let's just, to be it in slope-intercept form, y equals mx plus b, if you guys do this, just flip that y to the left. Notice that 2x minus 3 is the exact same thing. The exact same thing. So, great point, Angel. All right, we're going to do one more. Was there a question someone had? I thought I heard a mute or an unmute. We're good? Okay. All right, we're going to do number 3. Number 3 is tough. And on top of the clever assignment, I want you guys to everyone graph these 3 on your own later on for homework. If you got it done already, that's totally fine. So after you get your clever assignment done, I want you to come back to this page and finish, all right? We'll wait, for sake of time, we will wait to do 7, 8, 9, and 10. Remember those inequalities that we did? That was all last semester. That's a good review right there, okay? If you want to try them on your own, that's fine. So we're going to focus on number 3. So once again, this is for everyone, right? And let me check the chat real quick. Sorry, guys. Oh my gosh, I need some coffee. That's what's wrong with me right now. I haven't had any, well, besides my little sip before my ruck, I have all full thing of coffee right here. I haven't even poured it yet. Maybe I will in just a sec. All right, hold on. Talia, I got your text. Screenshotting right now, that's fine. If you guys want to screenshot this, that's fine. Okay, sweet. Okay. All right, number 3. So pretend this, my students, my Integrated Math 1 students. I give you a test question, one question worth, 100 points. What if on Aries right now, I went to Aries, plugged in a 100-point test, and it was one question? Would you guys answer, actually, let's do this. You could go to the chat, everyone go to the chat. You could type to me privately or publicly. Type in yes or no if you would think you could graph this line right here. So look at number 3. If I were to give you a one question, 100-point test, like literally, if you get it wrong, you get a 0 out of 100. Would you be able to graph it? So everyone go to the chat real quick. I should see 24 chats. Just type in yes or no. This is also my confirmation of you guys still being here, right? Or so I know a lot of you guys are. You guys wouldn't just get into a Zoom, turn your camera off and leave now, would you? And miss my stories about the sheriff, either stalking me or making sure I'm protected? Shoot. Okay, let me check. A lot of you guys are being honest. That's totally fine. Some of you guys are like, wait, let me try. Okay. Sydney says maybe. Good, good, good. See some yeses. See most likely. My man Jake says not sure. That's fine. No question mark? Maybe. I'm trying to do my head. Okay. Let's do this. Before we officially go on to page 125 or 124 in our notebook, everyone please try it. All right? So I really am going to be silence. I'm going to work it out in silence. Especially, even if you don't have your green student journal, try it on a piece of paper and graph it. You know, you can get the same thing. And then want to see what we get. All right? Especially for the ones that we're not sure. All right? All right, let's go.
Mr. Wallace, is it a negative? Because the graph is going to the left.
So, Angel, great question. If we have a negative slope, remember that it is going down to the right. Did you guys go down to the left? Did someone who went down 5 and then over 2 to the left? Let me see real quick. Angel. You got it. Dude, you got it. That's great.
Because it's going to the left. It's going like that way, like this.
What do you mean left? You mean down to the right? Because right now, like if I'm going down 5, over 2 to the right. What'd you say? Did you get it, Angel? Or no?
It's going down to the right.
Okay, there you go. There you go. So I saw what you graphed. It was correct. Very good job. All right. So I'm not going to have you guys go back to the chat. If you said yes and you got it right, guess what, guys? And this is, I mean, one hard thing about distance learning is that, you know, I can only do so much. Like, I literally want you guys to think to yourselves, if you got it, if you said yes to the chat and got it right, you're going to be good to go. All right? Marissa, I see a hand. What's up?
Sorry, my mouse wasn't working.
Oh, you're fine.
Wouldn't it, for a negative slope, if the mx is negative, isn't it always going to be a negative slope?
Yes. If the number before the x, great question, is negative, it is always going to be a negative slope. That means it's going down from left to right. So remember, from left to right, it's like reading a book. Left to right, it's going down. Look at numbers 1 and 2, guys. These were all positive slopes. Positive slope going up from left to right. Negatives go down. All right? Why, tell me, unmute real quick, and then we're going to move on. Why am I totally fine with getting a fraction for a slope? Someone unmute real quick, tell me why.
Because the bottom number just counts as where you're going. Like, the top number is going up a certain number, the bottom's going right a certain number, right or left.
Oh, man, you know what? Angel, I know I gave you a Whopping card last week. I'm going to give you another one. Oh, and by the way, where's Mac? Mac's in the house. Mac, you got you won! From last week I put, several people who got Wampum cards, and Mac ended up winning, so which was really exciting. So, Angel, I'm writing it down. Thank you, Angel. That was perfect explanation. if you guys didn't hear what Angel said, I'll recap. If you get a fraction for a slope, it is totally fine because that bottom number just tells us how much we are running to the right, right? If it's a negative slope, that means we're going down. How many are we going down? Oh, we're going down 5. Down 5, no matter what, we still go to the right. Down 5 over 2. Down 5 over 2. Notice for these, we went up because it was positive, but we still went to the right. This was negative, we just went down. Went to the right. You guys, and I'm not just saying this, and I don't mean to be negative or intimidating or anything. You guys, and I'm going to say this because it's second semester now, have to be solid with graphing this. If you can graph one line, you're going to have a lot of success this chapter, right? Yeah. All right. If not, I'm going to put this on YouTube, what I'm recording right now, and we're just going to be doing a lot of practice also. If not, that's okay. I don't expect 100%, I promise. I really just, that's the learning process, right? That's how we learn, okay? All right, I'm going to go deeper into it on Thursday, specifically what a system of equations is, but the broad stroke is that a system of equation are just a combination of two equations, all right, of two linear equations. So let's look. If we have a line right here, and this is something that we can graph, just like we did on our warm-up, and we have a line right here. Well, we have an x and a y, there's no exponents, so we know for sure we have two linear equations. When we have two or more linear equations, that is called a system, right? So number 1, number 2, number 3, number 4, number 5, number 6, these are all systems of equations. It's just a grouping. A system is just two equations on the same coordinate plane. Take a peek down at 7, 8, and 9. Well, let's look, and that's what I mean. There are two linear equations on each coordinate plane, so that is a system, right? We're going to be solving systems of equations. What's exciting in Integrated Math 3, everyone say Integrated Math 3, you solve systems of equations with 3 equations, 3 or more. In IM1, we're only doing 2, but when you guys are juniors or whenever you are, take Integrated Math 3, it's going to be good stuff. You solve using 3 different equations, and not just graphing, but a whole different other ways. Okay. All right. So we have a system of equations right here. All we are wanting to do is to tell whether the ordered pair, this ordered pair, 3, 1, is a solution. And how do we tell if it's a solution? We plug in each of the numbers and see if we get a true statement. So 3 is my x, and y is my 1. 1 is y. Because, right, the coordinate pair is x, y. So all I got to do is plug in 3 for my x, 1 for my y, and see if I get a true statement. All right, guys, it's that simple. I'm going to say that again. All I have to do is plug in my x's to the x's, y's to the y's, and see if it's true. Let's do it. If I plug in 3 for my x, 1 for my y, does 3 plus 1 equals 4? Everyone? Yeah. 3 plus 1 is 4. Check. Okay. We're not done yet. We have to make sure both systems work. All right. If we get 1, we check the other. Let's plug in 3 for my x, and then 1 for my y. Here we go. 2 times 3 is 6. 6 minus 1, well, right here it says equal 3. Guys, is 6 minus 1 3? No. So guess what? This is not a solution. 3, 1 is not a solution. All you have to put is no. All right? So you might be asking, and once again, we're going to go deeper on Thursday. What is a solution to a system then, Mr. Wallace? Well, let's look down at number 7 real quick. That point where the two lines cross is the solution. Whenever we have a system of equations, two equations, where the lines cross, that is the solution. So what happens with this number up here, the 3, 1, it's not a solution. That means it's not the intersection point. It satisfies one equation, but not the other. So that's probably something like this. You know, if there's a point on the line, it satisfies one of the lines, but it's not the intersection point, right? If it is a solution, then it's the intersection point, all right? All right, let's do number 2. Let's look at number 2. What time is it? Okay, got a little bit of time. Now, please, I want you guys to be following along in your Green Student Journal. Angel, you're playing catch with something. I don't know what you're doing. Make sure you guys, or if you work ahead, or maybe Angel's already done, I want you guys to please, this is not just for my benefit of giving you a show. Like, this is actually what I would like. Angel, I didn't mean to call you out, man. I'm sorry. I want everyone to be following along. And if you don't have your Green Student Journal in your notebook, all right, copying down the equations and giving you guys examples. Because if you can do this, then the clever assignment's going to be really easy, okay? All right, let's look at number 2. 1 is my x, 3 is my y. Let's plug everything in. I did the top equation. I plugged in 1 for my x, because that's what I got. Plugged in 3 for my y. Is 1 minus 3 negative 2? Yep. If it's a yes, I give it a check mark. That means we have to try the second one then. All right? Okay, let's try the bottom equation then. Let's plug in 1 for the x. Three for the y. Well, you got it now, Talia? Awesome, awesome, awesome. 2 times 1 is 2. Is 2 plus 3 equals 5. Yes! Oh, man. If we get 2 check marks, that means that this coordinate pair is the solution. That means it is the intersection point. And for these types of questions, I just want you to put yes. No, yes. Obviously, you got to do some work, but then at the end, you're just telling me yes or no, just like it is in your clever assignment. Yes or no. So, for example, again, if it is a solution, if we figure out it is a solution, all that means is that it is the point where the two lines cross, the intersection point, because that's the solution. That's the solution to a system of equations, the intersection point. We're going to do two more questions. I'm going to let you guys go because then we're done. Let's do number 3. All right. Actually, I want you guys to do this on your own real quick. All right. It's 8:55. We're going to be done in about 5 to 7 minutes. I'm going to get a dad joke real quick. So look at number 3. If you don't have your Green Student Journal, write it down. Tell me yes or no. Do we have a system of equations? I will do it and then put it in the chat. And don't peek at the chat. This is a great question, actually. Number 3. This is a great question. Text me privately. Text me private. That's fine. So that way I can really tell. Marissa, you texted me. Awesome job. You got it. You are correct. Very good. Mia, awesome job. You got it. Very correct. Perfect. Good job, Angel. Good job. Issa, very good job. You are correct. Good job, guys. All right, there's that. Good, good, good. A couple of you guys more texted me. All right, a couple of you guys have had. I'm gonna spoil it for you guys. A couple of you guys texted me no, so it is a solution. Just one question. So is the first one? I have a question. So if the first one is no, then you just say. Jarrett, great question. If the first one does not work, you can stop right there. All right, now I'm gonna go over that in a sec. Yes, on top. No, on bottom. Max says yes on top, no bottom. Okay. All right. So thank you guys so much for chatting with me. I really appreciate that. Okay. Let's look at this real quick. 2 is my x. So let's plug in 2 for x, 0 for y. Once you plug them in, the variables go away, right? So 0 for y is 2 minus 2, 0. Yeah. Yep, so that works, right? We just have 0 on the left. So the top equation works. Let's plug in 0 for y on the second one. And let's plug in, see how my x is 2? So I'm going to plug in 2 into my x right there, and that's just multiplication, right? It's back to back. -3 times 2 is -6. What is -6 plus 6? Oh, sweet. That also equals 0, right? If they both check out with the same coordinate point, that means that, yes, we have a solution. Are there any questions, guys? Any questions? Jarrett asked an amazing question. Jarrett, real quick, unmute yourself. Which one were you? Were you working ahead, obviously, Jarrett, or you just had that question?
Oh, no, I read number 3 wrong, but then it made me think of that.
Oh, got it. Okay. Jarrett asked a really good one. Let's just say we're looking at the first equation, and it doesn't work. Notice in 1, 2, and 3, the first one we did were all true. If we get one that doesn't work, the first off the bat, you can stop right there. It's just stop. You don't even have to do the second one, because if one of them doesn't work, then we know for sure it's not a solution, right? If we get at least one no, if we get at least one x, we can stop. It's not a solution, okay? All right? 4, 5, and 6, these are going to be our warm-ups on Thursday. All right, so you don't have to do 4, 5, and 6 for homework. It is going to be a required warm-up on Thursday. If you do want to get it done early, that's fine. Very last section, and then you guys are going to be done. When you log into Clever, so this is on your assignment. Guys, I promise this is probably the easiest Clever assignment ever. It's this, yes or no, and then this. The only thing that you need to do for these types of questions, 7, 8, and 9, is tell me the coordinate point of the intersection. That's basically it. All right? So this point right here, ignore this one right here. This intersection right here, and this intersection right there. Literally just give me the x comma y, the coordinate point. This point is 2, -2. Boom, done. Now, if we wanted to plug these in, this is where it says in the directions, check your solution. If you wanted to plug that coordinate pair into these two, like we did up here, to check your work, that's fine. I mean, obviously, they are intersecting at that point. It's going to work no matter what, all right? So this is more of just a test of your knowledge of the coordinate plane, because I promise you, this is all going to come together. All these different skills are we're going to have to use, okay? What is the coordinate point of this? All right, well, let's start at the origin. we're going left 1, so x is negative 1. And how many are we going down? 1, 2, 3. We're going down 3. There's my answer for number 8. What is the solution of this system? Well, I'm just identifying where they cross. And then last but not least, it is 903. What is the coordinate point of right there? Well, my origin's way over here. So my x, where's my x? 1, 2, 3, 4. What's my y value? My y is going up 2. And I'm done there. Pretty basic. Am I right? I try to avoid that question as a math teacher. Systems of equations. In a couple weeks, guys, when we do substitution and not graphing, right now this is all graphing. When we do substitution, that's where it's going to get hard. Really hard. But as always, I'm going to try to go through it at a good pace, relatively slowish, so we can kind of get a good grasp on it. I'm going to open it up for 10 seconds, take a sip of coffee. Any questions on 7 or 8 and 9? Literally, just like in the homework assignment on Clever, you're just putting in the coordinate pair.
Is it better if we go down first?
Angel, I love that question, man. I never want you to go down first. Don't go down. Because on a coordinate pair, it's always, think alphabetical. It's always x comma y, right? If you go down first, you would be tempted to put that number first, right? So for example, let's look at number 8. If we go down first, if I'm going -3, you might accidentally then put the -3 listed first. But that -3 is not my x value, that's my y value. And if you go over then -1, well, that would be wrong because that's y comma x. Coordinate points are always x comma y. Does that make sense? Angel? Awesome. Great question. Because these 2 points right here are totally different. -3 comma -1 would be right there. And that's not even on any of the lines. So that wouldn't be a solution to either of these equations if the point's not on the line. The reason why -1, -3 is a solution, because if you think about it, that point is on both lines. That's the point where they cross. All right. I had a lot of fun today, guys. I'm not just saying that. I loved story time with the sheriff and the rucking and you guys calling me a non-Irish terrorist. And we did some math. And I got what I wanted to teach across to you guys. So I'm going to stop share. Boom.